The lifting and moving of materials and machinery is a task that many of us have to carry out on a daily basis. And yet, though the job looks easy, it is nevertheless primarily responsible for around 90% of all foot and hand injuries in industry. Those of you involved in the lifting and moving of heavy loads should therefore work safely and help to reduce any risk of accidents. This series of programs is aimed at helping you to improve your knowledge and skill in the lifting and moving of loads in various conditions. At the end of this series of programs, you will be able to A. Identify and perform physical checks on typical lifting and moving equipment. B. Plan a task and decide which equipment would be best suited. And C. Perform lifts and moves in various conditions. The video programs in this series are to be viewed before performing practical exercises issued by your course controller. This is Module 1, in which you will learn to identify commonly used equipment and how to perform an inspection on such equipment. We begin by taking a look at wire rope slings, which are used extensively owing to their strength and flexibility. Wire rope slings are usually constructed in such a way that each end has a spliced eye used for attaching the sling to a hook, shackle, or other device. Wire rope slings are available in various thicknesses, as well as in various lengths. A typical wire rope construction consists of a flexible core, usually a natural fiber or polyester fiber, around which a number of outer wires are laid in a spiral formation. The outer wires are constructed with a bundle of individual wire strands. The number and diameter of wires in each strand determine the flexibility and the carrying strength of the sling. Wire ropes for slings are constructed with 6 strands. Each strand may have 19, 24, or even 36 individual wires. We usually refer to any size sling by its number and construction of strands, for example 6 by 19, 6 by 24, or 6 by 36. Standard sling diameters range between 10 mm up to 32 mm. The bigger the diameter, the heavier the load it can safely lift. Various sling lengths are available. Length is selected by the slinger, depending on such factors as load size and available room around and above the load. Every wire rope sling should display its Safe Mass Load Rating, or SML. This figure is normally stamped upon the ferrule. The figure may be given in kilograms or tons. When a sling does not display its SML rating, or the figures are unreadable, then determine its safe mass rating by measuring its diameter across the largest section. Square this figure, then divide by 100. The example shown is for a 16 mm wire sling. For greater accuracy, however, we suggest you follow the recommendation provided in chart form by leading wire rope manufacturers. Some slings are made using the so-called AF-grip crimp instead of a splice. Suppliers of such slings will provide you with a certificate proving that the sling has been tested and meets the required safety standards. Chain slings will next be discussed. Chain slings are constructed from a series of metal or alloy steel links. The ends of the sling will usually be attached to hooks or an oblong for attaching to a lift hook. Every chain sling must bear a certificate or label upon which its safe working load or SWL rating must be clearly visible. It is usual for sling users to have their own color coding system for slings and lifting equipment. Each color represents a certain safe mass load, which makes your selection easier. Stop the tape now and ask your course controller for the first discussion and practical task.